Hello, and welcome to another episode of Elemental Physics. Today's topic, physics in air.
Today we will be exploring the change in energy due to drag. I'm Georgia, and this is Kaylee.
So, Georgia, what exactly are we doing today?
Well, today we will be examining drag on a falling object. Drag is a reactionary force. As an object moves through a medium, air in this case, that medium exerts a force on it, drag. When the deceleration of drag matches the acceleration of gravity, the object will reach its constant and terminal velocity.
And in order to determine the drag, we will be examining the conservation of energy law. The equation we will be working with is E before equals E after. In this case, the gravitational potential is converted into kinetic energy. The energy is neither created nor destroyed. It's conserved.
So, in order to determine drag, we will be dropping a toy dog with and without a parachute. Using the slats on the side of the house, the mass of the objects, and the time of the fall, we can determine the object's velocity and the distance dropped, and thus their kinetic and gravitational energy. On a side note, we will be measuring the object's terminal velocity when we work with the parachute, as that is going to be its final velocity. Note how here the object falls faster and faster due to gravity. Whereas here, the parachute falls quickly for a few slats before reaching a constant and terminal velocity.
Now, we will be performing our experiment with the chewed-up dog. For our calculations, we started with the dog without the parachute, calculating its final velocity. We started with trial 1. Using the equation velocity final equals velocity initial plus AT and zeroing out the initial velocity since it's 0, we found the ending velocity, and we found that to be approximately 6.56 meters per second. Then we performed trial 2, and we found that velocity to be 6.174 meters per second. Finally, we found our average of the velocities to be 6.37 meters per second.
Moving forward, we then dropped the dog with the parachute in order to determine its terminal velocity. This time, for our calculations with the parachute, we used the equation, since velocity is constant, velocity equals distance divided by time. Giving us, for trial 1, a terminal velocity of 0.920 meters per second. And for trial 2, we found it to be 0.936 meters per second. All of this gives us an average terminal velocity of 0.928 meters per second.
Now, we're going to find the loss of energy due to drag. The equation we will be working with is energy before equals energy after. We will start without the parachute. The gravitational potential energy plus the initial kinetic energy, which is 0, is equal to the final gravitational potential energy, which is 0, plus the final or terminal kinetic energy, plus the energy lost due to drag. To start with the calculations, to find the energy lost without the parachute, we use the equation process aforementioned. When we subtract the kinetic energy from the gravitational potential energy, we get the energy lost due to drag to be 0.138 joules.
And with the parachute, we used the same process, except with the terminal velocity instead of the final velocity, as well as the combined mass of the dog and parachute dropped from the same height. This gives us an energy lost of 0.854 joules. As you would expect, comparing the energy lost with the parachute and without the parachute, the energy lost with the parachute is much larger than without. 98.456% is lost with it, and 27.22% is lost without.
One real-life application for drag is cars. Cars depend on drag greatly because less drag can help with gas mileage. The teardrop shape is the best for gas mileage.
Planes follow a similar idea. They work to reduce drag in order to improve their gas mileage too, and more importantly to stay airborne. Planes fly because more air goes under the wings than over, so getting it the correct velocity is important.
One last application for this, and debatably the most important, is that this saves the physics students from having to use that horrible drag equation because we can find the change in energy and find the energy lost due to drag.
And next time on Elemental Physics, fire!